So in this class we will solve some problems based on cells connected in series. Now take down the first one. 3 cells of EMF E, 2E and 5E having internal resistances R, 2R and 3R. And a variable resistance are 3 cells of EMF E, 2E and 5E having internal resistance R, 2R and 3R are connected with a variable resistance R as shown in the figure. Find the expression for the current. Let me draw the figure. E, 2E, 5E. Connected with a variable resistor. R. The value of this EMF is E. This is 2E, 5E. So the cells with EMF E, so it has internal resistance R. This has 2R and this is 3R. Expression for the current. So we'll find out the expression for current. We know the total current as net EMF divided by net resistance. Current I will be equal to net EMF of the combination divided by net resistance. Divided by net resistance. First, let us find out what is the net EMF of this combination. Net equal to net EMF of the combination, which is equal to, now we need to take the proper polarity here. So it is nothing but minus E plus 2e plus 5a, which is equal to 6e, because 7e minus e, that is 6e. Now we need to find out what is the net resistance. Net resistance of the combination. Net resistance is equal to, we need to take all the internal resistance, also the external resistance. It is R plus 2R plus 3R plus capital R, 6R plus capital R. Therefore, the current is, the expression for current is I is equal to 6A divided by 6R plus R. 6A divided by 6R plus R. Now take down another question. A cell of EMF E and internal resistance R is connected across a variable resistor R. Plot a graph showing the variation of terminal potential V with resistor capital R. So a cell of EMF E and internal resistance R. E and internal resistance R is connected across a variable resistor R. Plot a graph showing the variation of terminal voltage V with resistor capital R. So first we need to find out the expression which will help us to draw the graph. First find out the expression which relates the terminal voltage with variable resistor R. We know the terminal voltage V is this voltage. If I is the current in the circuit, we can write V is I into R, and we know I is given by E divided by R plus R. This is an equation, so we can write V is equal to I, which is E divided by R plus R into R. or this equation can also be written as E divided by 1 plus R divided by R. So R you get into the denominator, so that will become E divided by 1 plus R divided by R. Now with increase in R, if R value increases, R by R term will reduce, and when the denominator reduces, V will increase. We can write with the increase of R, increase of R, with the increase of R, V increases. This can also be clear from this equation, V is equal to I into R. So we can directly tell even from this equation, if R increases, V also increases. So let us plot the graph now. V versus R graph. As R increases, this term reduces, and hence V increases. This is, this will not reach like this. So at infinity it will reach the value of E. Sorry, I'll just draw it properly. So this is E. V versus R graph.